So here we are going to use the Euler's exponential form to check why the when the argument of the sine function is negative, that yields negative sine x. So let's do that. So we begin with the left hand side. So we'll start with sine x is given by e raised to the power of ix minus e raised to the power of negative x divided by 2I. Now we're going to substitute x with negative x, so that gives us sine negative x equals to e raised to the power of I times negative x minus e raised to the power of negative I times negative x divided by 2I, which is equals to e raised to the power I negative x minus e raised to the power of I times x divided by 2I. Now we're going to take negative 1 as the common factor, so that gives us e raised to the power of ix minus e raised to the power of negative ix whole divided by 2. Now we have negative times we also have the 2I here, so this is negative times the sine x function, so which we have got from equation number 1. So this proves that sine of negative x is equals to negative sine of x. So let's try that with the sine function as well. So we start the Euler's form. Cosine of x is equals to e raised to the power of ix plus e raised to the power of negative I times x whole divided by 2. Now we're going to substitute x with negative x. So that gives us cosine of negative x equals to e raised to the power of I times negative x plus e raised to the power of negative I times negative x whole divided by 2, which will be equals to e raised to the power of negative ix plus e raised to the power of ix whole divided by 2, and that returns back the original cosine function. So this proves that cosine of negative of x is equals to cosine of x.